In this video, we'll go on to the third example of finding the equation of the tangent line of a function that involves function composition. So we'll be using the chain rule. And our function y is equal to 4x cubed plus 3 quantity squared. And there's no need to rewrite that. We can begin right away to find the derivative using the chain rule. So y prime will equal 2 times, and then we'll reduce the exponent from 2 to 1, leave the inside alone, 4x cubed plus 3, then multiply that by the derivative of the inside, which will be 12x squared. And that first power, we can just take that away. Don't want that to be confused with the prime symbol for derivatives. So now we're ready to plug in x equals -1. So x cubed, -1 to the third power would be -1 times 4 is -4 plus 3 is -1. So that'll give us 2 times -1, and then -1 squared would be 1 times 12, and we're going to end up with a slope of -24. The point we want to find the tangent line at is -1, 1. So y minus 1 is equal to the slope, which is -24, times x minus x1, which would be x plus 1. And so we get y is equal to -24x, then minus 24, and plus 1, or y is equal to -24x minus 23. And we'll bring up the graphing calculator and take a look at it. And we'll put in our function, which is parentheses 4x cubed, x to the third power plus 3 quantity squared, and we'll go to graph that. We end up with a function that looks like this, and we want to find the derivative at x equals -1. So we want to find the tangent line, so we're going to go to second, draw, option 5, and -1, enter, and we get -24 minus 23, and so that checks out. Now you can't really see too much happening there because the graph, obviously with a slope of -24 at that point, is very steep. If you wanted to change the window to see that better, you would have maybe -5 to +5 for x values. And let's see if that makes it any different. And right at x is equal to -1, second, draw, tangent, x is equal to -1, and we get -24 minus 23, -24x minus 23. All the decimals there are just rounding errors in the derivative process on the calculator. So that does it for this collection of exercises. We're trying to use the chain rule to find a derivative and then to go on to find the equation of the tangent line at a given point.